Let's take a look at some sample problems from the textbook on page 52. We're working in section 2-2, and I'm going to begin with number 10. The directions are on the previous page, and we're asked to identify the class width, the class midpoints, the class boundaries for the given frequency distribution. Okay, so we have white blood cell count of females, and our classes go from 3.0 to 4.9, 5.0 to 6.9, 7.0 to 8.9, 9.0 to 10.9, 11.0 to 12.9, and one more 13.0 to 14.9. Those are our classes, and we have the following frequencies: 6, 16, 9, 7, 0, and 2. Okay, first of all, we're asked to find the class width. Class width is the difference between two consecutive lower class limits. So 5 minus 3 equals a class width of 2. So that's our first answer. Our next answer, we're asked to find the class midpoints. So let's make a column for that like I did in the notes. The midpoints, what we want to do is we want to take 3 plus 4.9 and divide it by 2. Let me see if I can grab my calculator here real quick to make it a little bit easier. Excuse me. Okay, 3 plus 4.9 equals 7.9. We want to divide that by 2. We get 3.95. 5 plus 6.9 gives me 11.9 divided by 2 is 5.95. 7 plus 8.9 is going to give me 15.9. Divided by 2 is 7.95. Now what you'll notice on each of these is a difference of the class width. So the next one would be 9.95. Saves you a little bit of computation. And 13.95, just adding 2. Okay, our next part is, let's see, we've done the class width and the midpoints. Then we want the class boundaries. So I'm just, hopefully I can squeeze this in. Class boundaries. Remember, we have step before 3, so that's going to be 2.95 to 4.95, half a step after. Half a step before is 4.95. The other way you could do is add 4.9 and 5 and divide by 2. Okay, 6.95. 6.95 to 8.95. 8.95 to 10.95. And that's going to be our half a step below, half a step above. Half a step below is the same thing, and then finally we end up 14.95. So that's number 10. Okay, 14, we're referring to number 10. It says refer to the frequency distribution in exercise 10 and ignore the given frequencies. Okay, so they're going to give us new frequencies. Assume that the first two frequencies are 2 and 6. Respectively, and we're to assume that there are 40 people. Okay, so we're to 2 and 6, so that means if it's a normal distribution, that would have to be a 2 and a 6. So 8 and 8 at that point. 14 we're doing. 8 and 8 we have 16 from the 40. We have 30. Sorry about that, 24. So both of these would have to be 12s in order for it to be symmetric. So we take 24 and divide it by 2, and that's how I get the 12. So for that to be true, those would be the answers for number 14, for it to be a normal distribution where we have a distribution of 40 sample values, assuming the first two have frequencies 2 and 6. Okay, now moving to number 24. Go to a new page here. All right. We're using a data set in the back of the book, data set 16 in Appendix B. We're to begin with a lower class limit of 1 and class width of 4.0. So let's see, we're doing earthquake depths. So I'm going to earthquake depths. Okay, they say to start at 1 and a class width of 4. So the next one would start at 5. The next one would start at 9. Add 4. And let's see. I don't know if we'll need to go beyond 17. Let's hope not. Okay, so this would be 4.9. We want to stop one step before. This would be 8.9, 12.9, 16.9, and let's see, we're adding 420.9. Oh, that would be. Okay, so we're talking about kilometers. All of those are in kilometers. Now, we want to go to data set 16 in Appendix B. It's all the way at the back of the book. Okay, we have two tables on the earthquakes on page 756. One is the depths and one is the magnitude. So we want the second one down there, the depths. And I'm going to go down the columns vertically, and so I'll start with 6.6, and what we need to do is make tally marks to take care of these. Where's my pencil? I want to make sure I mark these off too. 2.0, 15.3, 17.2. I may not actually finish this. We'll do a few columns. 3.2, 2.2, 14 rather, 0.8, 14.8, 5.6, 6.1, and 9.1. All right. 6.1 and 9.1, 18.5, 8.1, 10, 13.7, and 8.0, 13.7 and 8.0. All right, 7.0, 18.6, I think that's an 18, 19.1, 20.1, 21.1, 22.1, 23.1, 24.1, 25.1, 26.1, 27.1, 28.1, 29.1, 30.1, 31.1, 32.1, 33.1, 34.1, 35.1, 36.1, 37.1, 38.1, 39.1, 40.1, 41.1, 42.1, 43.1, 44.1, 45.1, 46.1, 47.1, 48.1, 49.1, 50.1, 51.1, 52.1, 53.1, 54.1, 55.1, 56.1, 57.1, 58.1, 59.1, 60.1, 61.1, 62.1, 63.1, 64.1, 65.1, 66.1, 67.1, 68.1, 69.1, 70.1, 71.1, 72.1, 73.1, 74.1, 75.1, 76.1, 77.1, 78.1, 79.1, 80.1, 81.1, 82.1, 83.1, 84.1, 85.1, 86.1, 87.1, 88.1, 89.1, 90.1, 91.1, 92.1, 93. Okay, we have 8.2, 5.7, and 18.9. Okay, now technically I should do the whole table, but I'm just going to do those first 4 columns so you get the idea. So our frequency, now we count the tally marks: 3, 8, 2, 3, and 4. So make sure when you do these that you do the whole table. I just wanted to do a portion so you would see what the process is. And as I recall, I think that's all we have to do for that one. Let me see. Okay, they ask us it says using a strict interpretation of the requirements for a normal distribution, do the depths appear to be normally distributed? Well, what I notice is those two are different, the first and the last. There's a really big difference if I look at these two. So my answer would be no. And I think even if you do all the numbers in the table, it's not normally distributed. I think the second class here is has way more values than any of the other classes, so it is not normally, okay, I'll put here, not normally distributed. Okay, so that's all there is to a frequency table. It's just a matter of setting up your classes, doing your tally marks to count off the values, and then simply counting your tally marks to say how many you have for each of the frequencies. And then looking at the frequencies, if the first and the last match, the second and the next to the last match, and then the ones in the middle match, but are higher, what you're looking for is this kind of situation. You want the highest value in the middle, and then the lower values should be the same as you approach that peak in the middle. So that's what we mean by a normal distribution. We can see the reason we don't have one here is the 4 and the 3 are too far off. If you do a strict interpretation, you'd really want those to match, like we did in number 10. Okay, that's enough to get you started on the homework.